My name is Taylor Lyons, and I'm doing my PhD at the Centre for Psychedelic Research in Imperial College London. And for my PhD project, I've been looking at the acute and long-term effects of psilocybin in healthy participants. I will begin by giving just a little bit of background information on psychedelics, and then I'll move on to discussing my study in more detail, and then I'll finish by summarising some of the core results, and I'll finish them with some questions. So as I mentioned, I've been researching psilocybin, which is a naturally occurring psychedelic drug found in so-called magic mushrooms. Psychedelics interact with the serotonin system to modulate our brain function, and by acting on the serotonin system, they produce profound effects on consciousness, and they have the ability to alter perception, cognition, and mood in a characteristic way. Psilocybin actually affects many different serotonin receptors, but it's its action specifically at the serotonin 2A receptor that seems to be responsible for mediating the weird and wonderful effects that we get with psychedelics. Research has shown that psychedelics can have long-lasting positive effects on healthy people and in patient populations. So, for example, psilocybin has been shown to increase optimism, well-being, life satisfaction, and openness in the long term in healthy people. And in patients, it has been shown to improve symptoms of addiction, depression, and anxiety, also in the long term. Recreational users have ranked psilocybin as the least harmful of all recreational drugs, and also one of the most beneficial drugs, with the most commonly cited benefits being the facilitation of psychological insight and improved well-being. But despite this, the facilitation of insight hasn't really been systematically studied in a controlled setting. Also, the long-term brain effects are not as well studied or understood. So neuroimaging studies in general have done the brain imaging actually during the dosing session itself or quite shortly after. And long-term brain imaging studies have tended to use recreational users and then comparing their data with that of non-users. So there's no true before and after in the same sample of people. And also you have the confound of recreational users have used different types of drugs, so it's unclear what's actually down to the psilocybin or the other psychedelics. So I wanted to fill this knowledge gap for my PhD by recruiting a completely naive sample of healthy people. So completely naive meaning they had never taken any psychedelic drugs before, and healthy meaning they had no previous or current physical or mental health ailments. And then looking at how their brains and psychology change in the long term following psilocybin. So to do this, I recruited 17 people in total using an online advertisement on the Centre for Psychedelic Research website. Again, they were all healthy, so no previous or current physical or mental health ailments. They were all psychedelic naive, so no previous experience, and they had a mean age of about 40 years old. I think the youngest was 29 and the eldest was in their late 50s. There was 9 males and 8 females, so roughly equal in terms of the gender. And the study involved 2 oral dosing sessions of psilocybin. So the first dosing session was always 1 milligram, and the second was always 25 milligram. The second dose was 1 month later. But we didn't tell the participants this. So simply, they were told they would receive psilocybin both times of a dose up to 25 milligram. And this was to control for expectancy effects. 1 milligram is believed to be a sub-threshold dose. There were EEG recordings done using a wireless EEG cap at different time points throughout the day. So EEG measures the electrical activity in the brain. So the participants wear a cap, and it contains these little electrodes that attach to the scalp, and this records the brainwave patterns. And there was also 3 fMRI scanning sessions. So the first scan was the day before the 1 milligram dose. The second scan was 4 weeks after to detect if there had been any changes after this low dose. And the third scan was 4 weeks after the large dose to detect if there was any changes in the brain after this. Psychological measures were given throughout the study, and there was also integration session the day after each dose. So this is just a schematic diagram to illustrate the study timeline and the design. Time is along here, the blue arrow line, in weeks. First of all, the participants came in for the first visit, which was a screening visit, and this consisted of routine health checks, checking their eligibility for the study, things like blood tests, ECG, neurological exam, and a mini psychiatric interview to check that they were indeed physically and mentally healthy so that they were able to take part. Then they came back in, providing everything was okay, and they had their second visit, and this was their baseline visit. So they completed some questionnaires, they had their first MRI scan, a few computer tasks, and also a dosing preparation session. The following day, they came in for the third visit, which was their 1 milligram dose. Again, EEG was done at different time points, and questionnaires as well. 2 weeks after this, they completed some questionnaires at home. And then after another 2 weeks, so 4 weeks after the smaller dose, they come back in and the whole process repeats again. So the scanning visit with a dosing preparation, questionnaires, computer tasks. The day after is the big dose this time, again with EEG and questionnaires. And then the following day, a second integration session. 2 weeks after that, they did the questionnaires at home again, and then 4 weeks after the big dose, they came in for their third and final scan to detect if there was any changes in the brain following the 25 milligram dose. So the dosing sessions themselves, I paid particular attention to the set and setting. So as I mentioned previously, we did some dosing preparation the day before, basically just sharing information about each other. I would ask them where they are in their lives, answer any questions they had about myself, discuss their expectations, what they wanted to get out of the study, and we then practiced some breathing techniques and stuff to help them relax if they would need that during the session. The dosing sessions took place in a nicely decorated room, so it was nicely lit, there were comfortable blankets, things to look at, nothing clinical in the room whatsoever. They were invited to lie down in a reclined position during the dosing session, and they wore an eye mask. And Roz, who will be speaking later on today, designed a fantastic playlist that mapped onto the psychedelic experience. So there was the come-up phase, a peak phase, and a come-down phase in the music, and this played simultaneously throughout the room as well as through headphones. So if the participant decided to take off the headphones, the music was continuous, it wasn't suddenly silent in the room. I was there to guide, together with another one of my team members, because there always is 2 guides in the room. But despite being called guides, it's more of a non-directive psychological support if required. And at the end of the day, when the effects of the psilocybin had wore off, we all sat and had a meal together. Okay, so this shows the time course of the psilocybin effects. So on each dosing day, the participants were asked to rate the drug effects from 0 to 10, with 0 being nothing at all and 10 being the most intense effects they could imagine. And this was done verbally every hour. And as you can see, the blue line corresponds to the 25 milligram dose, the orange line corresponds to the 1 milligram dose. And you can see that the bigger dose has much more intense effects at every time point. And you get this sweet spot at the 2 to 3 hour mark, which is known as the peak. As I mentioned, we did EEG throughout the dosing day at 4 different time points. This was resting state, so the participants didn't have to do anything. They just had their eyes closed and tried to stay as still as they could. Each recording lasted 11 minutes, and because the cap was wireless, it was much more friendly, especially considering the sample were psychedelic-naïve. So there was no annoying gels or no wires or the other things that we associate with traditional EEG. And the cap can also be easily taken on and off, so they didn't have to wear it for any longer than each recording itself. So as I mentioned, we did 4 of these. The first was a baseline, so in the morning before we give the dose. The second at 1 hour after the dose to catch the come up. Then at 2 hours after dosing to capture the peak, and then again at 4.5 hours after dosing to capture the come down. After each EEG recording, immediately afterwards, they rated the degree to which they experienced any insight, emotion, or visual imagery during the EEG recording itself. And this is what we found. So you can see from the graphs that there was significantly more insight, emotion, and visual imagery experienced during the EEG recordings at all the time points. And the curve generally corresponds to the intensity of the effects. So it increases to a peak at around 2 hours and then tapers off towards the end. With the resting state EEG data, we then did a fancy type of analysis known as Lempel-Ziv Complexity. And this is used to measure signal complexity, or the diversity of the brain signal. And it's generally used to index levels of consciousness. So for example, previous research has shown that in disorders such as the vegetative state or minimally conscious state, and also in non-REM sleep and during anesthesia, signal complexity is reduced. But it has also been shown that complexity is heightened during the psychedelic state. So we decided to look at this with the data, and we did indeed find that there was greater complexity following the larger dose. So the red dashed line corresponds to the baseline data. So this is the normal level of signal complexity before given any drugs. The 1 milligram dose didn't produce any change, but there was an increase in complexity following the larger dose. So it looks like this psilocybin-induced increase in signal complexity might reflect an increased richness of conscious experience or conscious content. And this doesn't seem to be the case. So 6 months after dosing, we asked a series of questions, the first being, how profound was your state of consciousness? You can see that no more than usual really for the low dose, but for the 25 milligram dose, 90% of the participants rated it as among the top 5 most profound states of consciousness they had ever experienced. We then asked, how intense was your state of consciousness? Again, not much for the low dose, but 100%, so every single person in the study rated the 25 milligram experience among the top 5 most intense states of consciousness in their lifetime. And then we asked, how unusual was your state of consciousness? Yeah. Yeah. And 95% said the single most unusual state of consciousness in their lifetime. So going back to the complexity measure itself, I was then interested in looking at how this would relate to the experience of insight. So as I mentioned, after each EEG recording, the participants rated the degree of insight they experienced during the recording itself. And you get this relationship. So this is called a linear regression. It's a method to see if changes in one measure can predict changes in another measure, so a relationship between 2 measures. And as the insight increased during the dosing session, so did the signal complexity. So the greater the insight, the greater the complexity during the EEG. To delve into the insight further, we then looked at insight in the integration sessions. So the integration sessions took place the day after each dosing session. They come in, they lay in the same position in the same room. They tried to relive the experience and the emotions associated with it as much as they possibly could. And then after they were finished doing that, we would work through their experience the day before together to try and integrate it. So the Mastery Insight Scale is generally used to assess insight gained during a therapy. And here the therapy would be the integration session itself. And you can see that following the 25 milligram dose, so the next day, working through the 25 milligram dose in the integration session showed massive increases in insight compared to the 1 milligram dose. We also looked at the gains from psychedelic interpretation questionnaire, and this has 3 different subscales. Experiential gains refer to the ability to re-experience the session and the emotions associated with it. The exploration insight gains refer to the insight that occurs as a result of exploring the experience again. And the insight action gains refer to the ability to change cognition and behaviour as a result of that insight. And you can see that on all 3 subscales, the 25 milligram session, integration session, produced increases in these. So next we looked at insight in the long term, and you can see that following the larger dose, the participants were still experiencing a facilitation of insight 1 month after the big dose. And they also stated that because of this insight that they were experiencing, that they had changed their behaviour. To confirm this, again, I did a linear regression, and indeed, insight does indeed predict the behavioural change. So the greater the insight, the greater the behavioural change later on. And we also found long-term increases in well-being. So after the larger dose, well-being was increased, and this was sustained for 3 months after the dose. Nothing much happened for the 1 milligram. And then to look at how insight related to this change as well, again, I did a few linear regressions, and you can see that the insight as well as the insight-induced behavioural changes were predictive of this change in well-being later on. So the greater the insights and the greater the behavioural change, the better the well-being outcomes were later. I also looked at empathy and personal distress, and you can see that empathetic concern was increased after the 25 milligram dose. There was no change for the 1 milligram dose. And personal distress was decreased following the larger dose. Again, there was no change after the 1 milligram dose. And the change in empathy, interestingly enough, was also related to insight. So insight at the integration session predicted this change in empathy later on. And the same thing with gratitude. So gratitude was increased following the larger dose, not much with the 1 milligram. And the increase after the 25 milligram was sustained for 3 months after the dose. And again, this seemed to be related to the insight during the integration session. So the greater the insights during the integration, the greater the change in gratitude and empathy later on. So this really shows the importance of an integration session to integrate your experience following a psychedelic session. Other effects were increases in the presence of meaning in life following the larger dose, also increases in compassion following the larger dose, and also connectedness to nature. All of these didn't change after the 1 milligram dose, and after the big one, they were sustained for 3 months. But these were unrelated to the insight, so these occurred independently from the insight. Okay, so moving on to the neuroimaging findings. So to reiterate, no one was placed in the scanner during the dosing sessions themselves. These were used to assess the longer term effects. So they were done the day before each dose, so the day before and 4 weeks later, to detect any long-term changes in the brain activity. There were 3 scans in total. So row number 1 refers to the baseline scan. So that was before any dosing, the day before the 1 milligram, without being given any drugs. The second row is scan 2, so that refers to the 4-week follow-up of the 1 milligram dose to detect if there had been any changes following that smaller dose. And the third scan was done 4 weeks after the 25 milligrams dose to detect any changes following that one. There was no difference between the 1 milligram before and after, so between 1 and 2. But there was a change following the 25 milligram dose, and these differences are highlighted in the bottom row by the green blobs. And what you're looking at here is resting state functional connectivity analyses. So the co-activation or the functional coupling between different brain regions. And this particular chart here is showing a region of the brain known as the ventromedial prefrontal cortex. It's a major hub of the default mode network, and it supports things like decision-making processes and things like that. And following the large dose of psilocybin, so 1 month later, we see a significant increase in the coupling of this area, the VMPFC, to the following regions, which largely correspond to the left frontoparietal network. And that's a flexible hub for cognitive control. Again, the numbers at the side refer to the scan sessions. So the first is the baseline, second is 4 weeks after 1 milligram, and the third is 4 weeks after 25 milligram. Same thing, there was no change between the first and second scan, so there was no difference after the 1 milligram dose. But following the 25 milligram dose, there was a difference, and this is highlighted in the bottom row by the green and blue blobs. So this refers to a region in the brain known as the subgenual anterior cingulate cortex, which plays a pivotal role in depression and also plays roles in things like prosocial and social emotions. And what you see here is that it also became significantly more functionally coupled to the following regions, which also largely corresponds to the left frontoparietal network. I'm not too sure what the story is behind these results, so if anyone has any ideas, you can let me know, but I need to look into it further. Okay, so the previous neuroimaging results were resting states, so they lay in the scanner with their eyes closed, they didn't have to do anything. This refers to an emotional faces paradigm, so they were instructed to open their eyes, and there's a screen in the scanner, and it presented a series of different faces that were expressing different emotions. So some faces expressing happiness, some expressing fear, and others just neutral to compare these against. And then we can look to see how the brain responds to the presentation of these different emotional expressions. And what we found was that after the 1 milligram dose, there was a difference. So we found increased responsivity of the amygdala, which is a region of the brain involved in emotional processing. And this happened 4 weeks after the 1 milligram dose and the big dose to happy faces. But what we found as well was that there was a decreased response to fear, but this only occurred after the bigger dose. Interestingly enough, this decrease to fearful faces after the big dose also was predictive of the long-term changes in well-being. So as the amygdala decreased in its response more to fearful faces, the greater the increase in well-being later on. So that's a lot of information, so I just want to briefly summarize the core findings of the study. I've showed you that related to the consciousness findings, that we had increased brain complexity at the peak of the 25 milligram dose, suggestive of an elevation of conscious content, and that this increased brain complexity also predicted the acute experience of insight. So as participants were experiencing more insight during the EEG recordings, their brain complexity was also increased. And this suggests that perhaps an elevated conscious content is required for insightful experiences. I also showed you that 90% described the 25 milligram dose, the experience, as among the top 5 most profound, intense, and unusual states of consciousness they had ever experienced. To sum up the longer-term psychological findings, we found that psychological insight was increased following the 25 milligram dose, and that this increase was sustained long-term, so there was a continued facilitation of psychological insight after the larger dose, and that this insight was predictive of long-term changes in behaviour, well-being, empathy, and gratitude. So it appears that insightful experiences induced by psychedelics might be mediating or playing a pivotal role in mediating the long-term positive outcomes that we see with psychedelics later on. I also showed you that we found long-term increases in nature connectedness, compassion, and the presence of meaning in life after the 25 milligram dose, and this was all sustained 3 months later. To sum up the brain data, there was increased resting state functional connectivity or coupling 1 month after the 25 milligram dose. So there was specifically increased coupling of the subgenual anterior cingulate cortex to largely regions that correspond to the left frontoparietal network, and also increased coupling of the ventromedial prefrontal cortex, also to areas of the left frontoparietal network. There was an increase in the amygdala response to happy faces 1 month after each dose, so the small dose seemed to be sufficient to facilitate this effect. But there was also a decrease in the amygdala response to fearful faces 1 month after the larger dose, and that this was predictive of long-term changes in well-being. To finish, I just want to acknowledge my team, so my supervisors, Robin and David, and everyone on this list played a substantial role in the study, either by helping me guide or providing medical cover or doing some of the analyses that I have presented here today. Also the Beckley Foundation and the MRC for funding me, and Invigro, the scanning centre, and the Imperial Clinical Research Facility for hosting the dosing rooms, the rooms for the integration, and also for the screening facility. Thanks very much. Cheers.